Alright, so in this video we're going to be looking at the problem. A straight wire of length 0.75 meters is orientated along the positive y-axis with a current of 2 amps flowing in the positive y direction. A uniform magnetic field of strength 0.3 Tesla points in a negative x direction. What is the magnetic force on the wire? Alright, so we have current here flowing in the positive y, and it's in a uniform magnetic field pointing in the negative x direction. Alright, so force is going to be equal to the current times the magnetic field strength times the length of the wire. And I don't have to worry about the sign of phi here, or doing a cross product, because I've already established the current, which has the drift velocity in it, and the magnetic field strength are 90 degrees from each other, so we don't have to worry about the cross product. So I'm going to plug in my 2 amps, my 0.3 Teslas, and 0.75 meters given in the problem, and I can establish that this force acts in the positive z direction, because I'm going to point my fingers up in the positive y direction, because the drift velocity is inside the current, and I'm going to curl my fingers to grab the end of the magnetic field vector here, which is going to cause my thumb to point out of the border in the positive z direction.